All right, good morning, everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up 107's on the screen. Let's get started, please. Shouldn't take you more than about 5 minutes. From there, get a Cornell note ready, please. We're moving on, and we're finishing up today. Copy and go. All right, here we go. Number one. For the function f of x equals 2 to the exponent of x minus 2, for negative 1, we got 1/8, and for 0, we got 1/4. Hands if you got that. All right. For the function f of x equals 10 to the power of x, f of negative 1 is 1/10, and f of 0 is 1. Number 2, we need to rewrite the transformation by putting a 1 there, so we end up with g of x equals 1/2 f x minus 1 cubed plus 3. And of course, we know that this one shrinks it or compresses it. We move 1 to the right and 3 up. Number 3, should have put a 1 here as an exponent for number 3. Distribute the power there and there. You end up with 3 to the negative 4, b to the 12. We can't have a negative exponent, so this becomes 1 over 3 to the 4th, b to the 12th, which is 1 over 81, b to the 12th. Number 4, a to the x over a to the 5th. And number 5, the inverse. Tell your neighbor what's the first step in getting the inverse. Looks like Alyssa's got it. Very good. See, Jessica's got it. Very good. Delilah's got it. Noel. Caleb's got this. Let's go. What's our first step, Jaden? Very good. Set it equal to y. 1/4 x squared. You guys forgot already? Come on. Let's go. From there, we need to solve for x, which means I need to get rid of this 4 times 4 times 4. You end up with 4y equals x squared, because 4 times 1/4 is 4 over 4, which is 1. How do we get rid of this squared? Square root. This cancels that. We're left with square root of 4 is 2. Square root of y equals x. What makes it an inverse? Tell your neighbor what to do to make it an inverse. How's it? One. Lorena. Switch the variables. That is correct. 2 square root of x equals y. And then we rewrite it in function notation. 2 square root of x equals f inverse of x. Yeah, Lorena from the corner. Let's go. All right. Copy the agenda for today. Warm-up 107, rational functions. Home plate pages 413, 414. I'm going to upload those in a little bit. Make sure you get those done. And with today's lesson, we're going to be done with rational functions. So make sure you do your practice, because maybe I won't pick up the home plate and replace that with what, Briseda? Let's go. Partake. All right, get a Cornell note ready, please, so we can get started. Use some time for that. All right, shall we? Yes? All right, here we go. Our objective for today, I can write, solve, and graph rational functions. And since we already know the definition, tell your neighbor the definition for rational functions, please. Definition. All right, good communication. Right on the screen, 30 seconds. All right, thank you. A lot of you write functions with fractions. Some of you wrote equations with fractions. So yeah, in your own words, equations with fractions. That's what we've been looking at. We talked about the general rule. We talked about asymptotes. And then last week we got into the slant or oblique. So here's our road to where we are at right now. Look up to the screen. Quick recap. We started with f of x equals 1 over x. If we follow the different transformations, this is what they look like. But the graph remained the same. A positive graph, that's 1 over x, looks like this. However, if we put a negative on it, it flips, so it looks like that. From there, we went to the next set of rationals with the x squared on the denominator. If we follow it, all the different transformations, and it looks like this in a positive. However, if we add a negative in front of it, it flips it. There it is. At the end, we did some more transformations with quadratics, and it looks like this. Two different asymptotes for the verticals. This one with a slant asymptote. All right, so today, we're going to continue with our asymptotes. We already covered vertical, horizontal, and slant. However, today we're going to talk about something that we say and we call discontinuities. In other words, it comes from the word discontinue. What does that mean? That there's going to be a gap or something missing because it's not continuing. So in our graph today, you're going to see how the graph is missing a portion of the graph, and that portion is what we're going to call today hole or holes. There's going to be holes on our graph. All right, so let's get straight to it. And like I said, since you guys are my awesome students that always do your home play, today you should be able to recall all the different skills for this one problem that we're going to do. So copy this one. Example 1. It says, rewrite the function and graph, identify asymptotes and holes. Function given, g of x equals x minus 3 over x squared minus 5x plus 6. All right. So I'm going to write the steps over here on the side. Step 1, factor and rewrite. Factor and rewrite. Okay? Here we go. If you look at the numerator, it looks like it's already factored. However, if we were to do the GCF for this, what would be a possible GCF? Briseida. 1. So let's write it 1 times x minus 3. Next, how do we factor the denominator? Tell your neighbor, please. Fabian? Six, negative 5. Factors of 6 that add up to negative 5, everyone. Negative 3 and negative 2. So my factors are x minus 3, x minus 2. All right, so step 1 done. Step 2, ID, tell your neighbor what that means. ID a giant 1. See if they remember. And then rewrite. Do you guys see the giant 1 there? Yes, here it is. And let's rewrite whatever we have left. Whatever we have left is g of x equals 1 over, oh, I didn't write the x on this one, x minus 2. X minus 2. Okay. So, really quick, writing utensils down, look up to the screen. Ready? Focus or you're going to miss it. Here it goes. Now, notice we end up with this function, but we had this as a function. So why did we end up with this? Because we took something out. Is that correct? What did we take out? This. That's what we call a whole. However, we start with this. What is it that we took out? We took out x minus 3 top and bottom. If we write it, set it equal to 0 and solve for x, that's going to give us the x value of the whole. So write that down. X minus 3 equal to 0. To solve, I add 3, x equals 3. There's my x value. How do I find my y value or my g of x? Well, we use this portion. So I would write 1 over blank minus 2. And instead of the blank, which is x, I write what? 3. So what is 3 minus 2? What is 1 over 1? 1. So for step 3, I'm going to write on the side, step 3, whole. That means we got to find the x and the g of x. That's what we did here. How do we get the x? Well, whatever we took out, we set it equal to 0. And then for the g of x, we just use whatever's left, substitute x, and that's how we get that. And step 4, graph. Here we go. So I'm going to write whatever we have left, g of x equals 1 over x minus 2. All right, how do we graph this? Tell your neighbor, what is it that we need to graph that? All right, good conversations. Diego Romo. How do we graph? Delilah, help him out. We got the whole, but how do we start graphing this function? Frida, help him out. So we need a vertical asymptote, x equals, and what else do we need? Yeah. All right, so what is our VA? 2, and our HA? 0. Okay. Two. So to graph our function, we need to, the parent function for this, our parent function, look up, this is what we end up with. What's our parent function for that one? 1 over what? X, which means it needs to look like this and like this, which means that this point is 1 up, 1 to the right, and this point is 1 down, 1 to the left. Is that correct? Now check this out. I'm counting from where both asymptotes meet, not where the coordinate plane is at, the point of origin. So let's see. Where do both of them meet? Here and here. So that means I need a point at what? One up, one to the right. So I go one up, one to the right. There's my point. And we need one to the left, one down. And some of you are wondering, Mr. Hugh, but I thought you said we're going to have a discontinuity on our graph. Or in other words, we were going to have a what? A hole. Where's that hole? 3, 1. 3, 1. So that means there cannot be a point there. So I'm going to erase that. And instead of a closed point, it's going to be an open point. You're like, what? I know, right? And there's the hole. That makes sense? Yes? From 1 to 5, I'll come provide you with this. Yeah, 4, 4, 4, 4 is okay. That means we need another one. Yeah, let's go. But before that, send me your work. Hold on. Let me send you a screen. All right, well, you send that in. I have a new example on the screen over there. We got g of x equals x plus 2 over x squared plus 3x plus 2. That's example 1Q. Very similar to the one we just did. I'll give you a head start. You should be able to do that one by yourself. Copy and go. All right, check your work on the screen. Hands if you're up to right there. All right, so help me with a graph, please. Oh, before I call on someone, tell your neighbor the parent function for that one so that we know where we're going to graph our graph. F of x equals what? 1 over x, yes. All right, so help me out with a graph 1. Where do I place my first point? -2 what? -1, okay. And the other one? 0, 1. That is correct. However, what's our hole, everyone? -2, -1. So here I replace that point with, instead of a solid point, it's going to be an open point. Hands if you got that by yourself. All right. From 1 to 5, I'll come provide you with these. Yeah, 5 4s, 5 4s, okay. All right. Let me send you the screen for the new one. All right, example 1 super Q reads g of x equals x squared plus 7x plus 12 over x squared plus 4x. All right, tell your neighbor the first step, please. What is the first thing we do? All right. What is the first thing we do, Alyssa? Okay, factor and rewrite. So tell your neighbor the factors for the numerator and the factors for the denominator, please. All right. Anaya, factors of 12 that add up to 7. 3 and 4. So my factors for the numerator are x plus 3, x plus 4. We need the denominator now for factor. Pass someone, Anaya. Jessica. That is correct. X and x plus 4. So far so good, yes? All right, identify the giant 1. You guys see the giant 1? Yes, there it is. Rewrite whatever we have left. And we're left with x plus 3 over x. So what did we just eliminate over here? We created a hole. So we need our x value for that hole. So we write x plus 4 equal to 0, negative 4. All right, now we need our y value, or our g of x. However, look up to the screen, guys. There's something funky about this function. Look at the previous ones. So you notice what you notice about the previous ones compared to that one. What do you guys notice? What do you notice, JP? So this one compared to the other ones, he said, yeah? Yes. Did everybody hear that? Okay. Now I'm going to put it in simple words. There's no 1 on the numerator. You guys notice that? So how can we do that? What can we do to get a 1 on the numerator? Let's see. Tell your neighbor before we get Briseida to enlighten us. Briseida. Yeah, divide. X plus 3 divided by x. Let's go! So, what times x gives us 1x? Well, 1. 1 times x is x. Subtract. Bring down the 3. And that is going to be our remainder. So, how do I write this? This is 1 plus 3 in the numerator over x. So, according to this, tell your neighbor the new function. What is our new function? All right. What's our new function, Frida? That is correct. So now we can use this to find our y value over here. So I'm going to do that in blue. 1 over x times 3 plus 1. But instead of x, I'm going to substitute negative 4. So what is 3 times negative 4? Negative 3/4 plus 1. Negative 3/4 plus 1. What is that? 1/4, yeah? Or you have $1, take away 3/4. Yeah? All right. So, VA, X equals HA, Y equals. So our HA is 1. Our VA, since there's nothing there, it's 0. Oh, my bad. That is incorrect. Our VA is up and down, sorry. HA is at 1. All right. Now for this one, look up. I'm going to start with the whole. Where's the whole at? At negative 4 1/4, negative 4, and positive 1/4, so it's about right there. All right. Now before I graph the other point, look up to the screen. Look at the graphs for the previous ones. This point is 1 down, 1 to the left. I'm sorry. Yeah, 1 to the left, 1 down. This one is 1 to the right, 1 up. This one, the whole is at 1 to the left, 1 down. The point is 1 to the right, 1 up. Okay. Where is this hole at? From here. Let me highlight the asymptote so you guys can see it. It's at 1, 2, 3, 4 to the left and a little bit down. So tell your neighbor where we're going to place the other point on this side. We're going to place the other point on that side. All right. Briseida, pass someone. Fabian. Positive 4, and what else? Okay, positive 4, so far so good, yes. Help them out, Christina. 1 and 1/4? Yes, that is correct. Write that down, please. So what are we talking about? That wherever the hole is at, make sure you reflect the other one to the other side whenever it comes to these kind of graphs. Yes? All right, let me send you the screen so you can send me your work. All right. Example 1, super duper Q is on the screen. Copy that one. You should be able to do that one completely by yourself. Copy and go. All right. So check your work on the screen. And if you got something like that, all right. Just make adjustments. Some of you are getting a little confused with the division portion. All right, send me your work, please. And then I'm going to send you a blank screen a little bit. And for those of you that are watching online, I'm going to stop the video right here. Get some practice in for your rationals with holes. A good one. Bye.